Imagine standing in front of a solid wall. By every rule of common sense, you shouldn't be able to walk through it. Yet in the hidden world of physics, particles are doing exactly that, slipping past barriers as if those walls weren't even there. This isn't science fiction. It's happening inside your body right now. What if the obstacles you see in your own life, the patterns that feel unbreakable, the limits that seem impossible to cross, were not as solid as they appear? Modern physics suggests they aren't. You see, at the quantum level, matter doesn't always play by the rules we expect. Instead of being trapped, particles sometimes escape impossible situations. Scientists call this quantum tunneling, and without it, the sun itself would not burn, and life as we know it would never exist. That's the stake. The universe itself only works because impossibility isn't absolute. In this video, we're going to explore what quantum tunneling is in simple, everyday terms. You'll see the strange experiment that proved it, the hidden way it fuels the stars, and why this phenomenon reveals something far bigger. That reality itself is porous. To understand tunneling, we need to first shift how we imagine particles. In school, we are often taught that particles are tiny balls, like miniature marbles, moving through space. But quantum physics paints a very different picture. At this level, particles behave more like waves of possibility than solid objects. They don't just sit in one spot or move in a straight line. Instead, they spread out like ripples on water, existing as a cloud of potential positions until they interact with something. Quantum tunneling happens when this wave of probability meets a barrier it shouldn't be able to cross. Picture a ball rolling toward a hill that is too tall to climb over. Classical physics says the ball will roll back, stuck on its side of the hill forever. But in the quantum world, the ball is also a wave. A part of that wave extends into the hill itself, and in rare cases, it shows up on the other side. To our eyes, it looks like the ball has passed straight through the hill, even though it never had the energy to climb over it. A simple way to imagine it is like a ghost moving through a wall. Except in this case, it isn't fiction. It is measurable, predictable, and tested in laboratories around the world. This phenomenon is not just a curiosity of physics. It is woven into the very fabric of reality. Without tunneling, the sun would never shine. The core of the sun is filled with hydrogen atoms, each carrying positively charged protons. By normal physics, these protons should repel one another endlessly, like magnets forced together at the same pole. The energy needed to make them collide and fuse is far greater than what the sun's temperature can provide. Yet fusion still happens, fueling the light and heat that makes life on Earth possible. The reason? Quantum tunneling allows protons to slip through their repelling barrier and merge. The fire of the sun exists because impossibility gives way to possibility at the quantum scale. It does not stop there. The same principle is quietly powering parts of modern technology. One example is the scanning tunneling microscope, a device so sensitive it can map individual atoms by detecting electrons tunneling between a sharp needle tip and a surface. Another is flash memory, the technology behind your phone's storage, which relies on tunneling to trap and release electrons inside tiny circuits. Every time you save a photo or a message, you are depending on this strange ghost-like process. Think about the scale of this. The same effect that lights up the sun also allows you to carry entire libraries of information in your pocket. Tunneling is not an exotic event. It is the quiet rule beneath both cosmic fires and the technology of everyday life. What this shows us is simple but profound. Matter is not bound by the rigid walls we imagine. Barriers that look impenetrable at one level can, under different rules, be crossed. This is the strange world of quantum tunneling, a world where what seems impossible often turns out to be essential. Quantum tunneling might sound abstract, but it is not just an idea on paper. Physicists have carried out experiments for nearly a century to show it is real, and some of the most important discoveries about it came from studying radioactive atoms. In the 1920s, a physicist named George Gamow proposed that tunneling could explain a mystery: how particles escape the nucleus of an atom. Inside an atom, the nucleus is a dense cluster of protons and neutrons. Protons carry positive charge, so they strongly repel each other. Nuclear forces hold them tightly together, creating a barrier that should trap them. Yet scientists observe that certain atoms naturally give off alpha particles, which are 2 protons and 2 neutrons stuck together. By classical rules, these alpha particles should never have enough energy to break through the nuclear barrier. Gamow's idea was that they did not break through at all. Instead, they tunneled their way out. This was a radical explanation at the time, but experiments confirmed it. Radioactive decay became one of the first clear proofs that tunneling was more than theory. The fact that we can measure the rate of decay in materials like uranium or radium is living evidence that tunneling happens constantly in nature. Later discoveries pushed the idea even further. In superconducting materials, researchers found that electrons can tunnel through insulating barriers in what are called Josephson junctions. Imagine 2 metals separated by a very thin layer of non-conducting material. Classical physics says electrons should not be able to cross that gap, yet experiments showed that they do, slipping across without resistance. This effect was not only fascinating, but also useful, leading to highly sensitive detectors of magnetic fields and new kinds of electronic circuits. These demonstrations carry a powerful message. Tunneling is not rare or accidental. It is a predictable feature of quantum mechanics. What began as an explanation for radioactive decay grew into a principle that could be engineered and applied. The credibility of this idea rests on more than one person's insight. After Gamow's proposal, decades of experimental work backed it up. Researchers could measure the energy and behavior of particles escaping atomic nuclei. Engineers could design devices where tunneling currents became measurable and controllable. Every step proved that nature allows matter to do what, on the surface, should be impossible. The stakes are huge because tunneling is not just about subatomic events. It shapes both the natural world and the man-made world. Without it, stars would not burn, radioactive decay would not occur, and many of the technologies we rely on every day would fail to exist. In other words, tunneling is not a side story of physics. It is a central part of how the universe functions and how human innovation has unfolded. When we look at these experiments, we are not just observing particles escaping barriers. We are being reminded that the structure of reality itself is not as fixed as it appears. Classical physics, the kind that explains falling apples and moving cars, treats barriers as absolute. A wall is a wall. A hill too steep cannot be climbed without extra energy. Everything follows clear, rigid rules. Quantum mechanics tells another story. At the smallest scales, matter does not move like solid marbles, but as waves of probability. These waves reveal that what we call walls are not truly solid. They are regions where the likelihood of passing through is low, but never zero. Nature leaves doors cracked open in places where our senses see only brick and stone. This is why Niels Bohr once said, "Everything we call real is made of things that cannot be regarded as real." It is not that the world is an illusion, but that it is less concrete than it seems. At the foundation, the universe is flexible, uncertain, and alive with possibility. This flexibility carries profound meaning beyond physics labs. If nature does not honor hard borders, then perhaps the limits we feel in our own experience are not as absolute either. Think about mental blocks, emotional scars, or even the sense that life is trapped in repeating patterns. They seem unshakable, yet quantum physics suggests that what looks immovable may actually be porous. This does not mean human challenges can be bypassed in the same way an electron tunnels. The connection is more symbolic, but still deeply instructive. Just as particles are not confined to the obvious path, consciousness itself may have hidden ways of moving through the walls we perceive. Mystical traditions across cultures have long spoken of dimensions beyond the visible, subtle fields of energy and unseen doorways. Physics is not proving these ideas, but it is giving us a language to imagine them with fresh clarity. Think of it this way. If the building blocks of reality do not treat barriers as final, then it makes sense that human experience also contains possibilities beyond what looks certain. A barrier in thought, emotion, or perception may not be the end of the road, but an invitation to discover a hidden passage. The stakes for you are not about learning complex math. They are about recognizing that the cosmos itself is built on probabilities, not certainties. The walls you face in life, whether internal or external, may feel absolute, but physics shows us that nature does not agree. If particles can cross barriers that appear impossible, it raises an intriguing question. Could consciousness itself do something similar? Physics has already shown us that matter is not bound by rigid walls. What if the same principle applies to awareness, thought, and even the deeper layers of the human spirit? Moments of sudden clarity often feel like tunneling. You might wrestle with a problem for days, convinced there is no way forward, only to wake up one morning with the solution fully formed in your mind. Or you might experience déjà vu, that strange sensation of being in a moment you feel you have lived before. In both cases, something in the mind seems to have slipped past the ordinary boundaries of time and thought. Some scientists have explored this possibility seriously. The Penrose-Hameroff-Orsh-OR theory, for example, suggests that consciousness may emerge from quantum effects inside microtubules, the tiny structures within brain cells. While still debated, the model offers a fascinating bridge. It means that awareness itself could be influenced by the same rules of probability and tunneling that shape particles. If this is true, then flashes of insight or mystical openings may not be accidents. They could be expressions of the mind shifting through barriers in the same way matter does. Across spiritual traditions, we find similar descriptions. Mystics have spoken of inner breakthroughs, where the soul steps beyond old limitations into higher states of being. In Buddhism, these shifts are described as sudden awakenings. In Sufism, they are moments of unveiling, where a deeper truth pierces through ordinary perception. Quantum physics does not confirm these teachings, but it gives us a framework to understand how they might be possible. Imagine your patterns of thought as a kind of mental landscape. Some paths feel fixed, looping back into the same fears or doubts. Yet, if consciousness functions like a quantum system, it may not be locked into those paths forever. Just as an electron can appear on the far side of a barrier, your awareness can sometimes leap into a new state that once felt unreachable. This perspective reframes experiences many people quietly carry. Those times when you suddenly feel connected to something larger than yourself, or when a creative idea bursts forth fully formed, may be examples of consciousness tunneling. They reveal that the boundaries of mind and self are not as strict as they seem. The significance is not only personal, but cosmic. If the building blocks of matter and the fabric of consciousness both reveal porous boundaries, then reality itself is more interconnected than we imagine. The barriers between self and universe, inner and outer, may be less like solid walls and more like thin veils. If consciousness can tunnel the way particles do, then the barriers you face in life may not be as absolute as they appear. This does not mean difficulties vanish or that everything becomes easy, but it does suggest that what feels like an unbreakable wall may actually be a threshold. Think of the habits you have tried to change but keep falling back into. It might be a cycle of self-doubt, procrastination, or repeating the same mistakes in relationships. These patterns often feel like a closed loop, as if you are circling inside a maze with no exit. Classical thinking says that unless you apply more energy, more force, you will stay stuck. Quantum thinking introduces another possibility. There may be hidden openings that let you slip through into a different way of being. The same applies to fear. Fear often appears like a towering wall that blocks progress. From the outside, it looks solid, but what if fear is more like a barrier of probability? Most of the time, it resists you, but it is not airtight. Like particles in physics, your awareness carries the chance of passing through, of finding yourself on the other side without brute force. This is not about forcing positivity or repeating affirmations. It is about recognizing that the field you live in is one of possibilities. Physics has already shown us that the universe does not run only on certainties. Every moment contains probabilities, some less likely than others, but none ruled out entirely. The same law that allows electrons to tunnel through barriers also reminds us that change is always possible, no matter how improbable it seems. The spiritual traditions echo this truth in their own way. In the Bhagavad Gita, Krishna describes life as a battlefield where perception can either blind us or free us. In Christian mysticism, the idea of grace often points to breakthroughs that feel undeserved yet transformative, like a door opening where there seemed to be none. Both perspectives suggest that what looks final rarely is. If you reflect on your own life, you may recall moments where you felt stuck, only to suddenly move forward in a way you could not have planned. Perhaps you met the right person at the right time, or a new idea shifted everything, or a deep fear dissolved after years of resistance. These experiences are glimpses of how limits are not the end of the story. Quantum tunneling offers a metaphor and a mirror for these moments. It shows us that walls exist, but they are not perfect. There is always a chance to move through, to reappear on the far side of what once felt impossible. The universe itself runs on this principle. Let's widen this view even more. If tunneling is written into the laws of physics and mirrored in moments of consciousness, then the question becomes larger. Could the same principle apply to dimensions of reality themselves? The idea may sound extraordinary, but tunneling already teaches us that boundaries are not absolute. A wall that looks impenetrable can be crossed. A barrier that appears final may have hidden openings. Why should the fabric of dimensions be any different? In physics, dimensions are not abstract poetry. They are the frameworks through which reality unfolds. We experience 3 dimensions of space and 1 of time, yet theoretical models such as string theory propose that more dimensions exist, folded beyond our perception. If particles can tunnel through walls in our visible world, then perhaps consciousness can tunnel through the thin veils that separate dimensions. This perspective helps illuminate experiences that often feel mysterious. Déjà vu, for example, is the sensation of standing in a moment you have already lived. From a dimensional view, it could be interpreted as consciousness briefly slipping through to an overlapping reality, glimpsing a parallel possibility before returning. Similarly, dreams that feel more real than waking life may be encounters with layers of existence our ordinary senses cannot usually access. Mystical traditions have long spoken of such crossings. In Taoism, there are references to moving between worlds within worlds. In Kabbalistic teachings, hidden dimensions of creation are described as both near and inaccessible, separated by veils of perception. Quantum tunneling gives us a scientific metaphor for these ideas. It shows us that movement across barriers is not only possible, but essential for the universe to function. Consciousness, too, may not be bound by a single timeline or a single world. This does not mean we can simply wish ourselves into alternate realities. It means that the structure of reality may be more flexible than our senses suggest. Just as electrons appear on the far side of barriers, consciousness may occasionally reveal parallel pathways, offering glimpses of lives not chosen or futures not yet lived. These are not fantasies, but reflections of how deeply porous the universe may be. The importance of this perspective lies in humility as much as in wonder. Tunneling reminds us that the cosmos is stranger and more layered than our ordinary view. Rather than claiming control over dimensions, we are invited to recognize that reality itself carries hidden doorways. The spiritual task is not to force them open, but to become aware that they exist. By bridging quantum science with ancient mysticism, tunneling becomes more than a physics concept. It becomes a lens to see life itself as interconnected, fluid, and multidimensional. Every boundary, whether in matter, mind, or dimension, carries the possibility of passage. In the closing section, we will return to the heart of this message. Quantum tunneling reveals that barriers are not absolute. The question that remains is whether you are willing to see the walls in your life not as prisons, but as probabilities waiting to be crossed. We began with a wall, something solid, something absolute. At the quantum level, physics revealed that even the strongest barriers are not final. Particles can slip through what should be impossible, and without this, the sun would not shine, atoms would not transform, and technology we rely on daily would not exist. As we followed this thread, we saw how tunneling does more than explain physical phenomena. It offers a profound metaphor for human experience. Just as particles pass through barriers, consciousness seems to find hidden ways of breaking through thought patterns, emotional loops, and even glimpses of dimensions beyond the ordinary. Mystical traditions have spoken of veils and awakenings for centuries. Quantum mechanics does not prove them, but it gives us a language that makes them more imaginable. The message is clear. Reality is not as solid as it appears. Physics has shown that walls are often probabilities disguised as certainties. This means the limits you feel in your life, the repeating cycles, the fears that seem immovable, the boundaries of perception, may not be final either. They may be thresholds. The universe itself is built on openings, not endings. If the smallest particles can move through barriers, then possibility is woven into the deepest fabric of existence. Your own life, with all its struggles and desires, belongs to that same fabric. So perhaps the real invitation of quantum tunneling is not only scientific, but personal. To recognize that what looks unchangeable may contain a hidden path. The barriers you see are not absolute. They are probabilities. And probabilities can be crossed. The question is not if crossing is possible. The question is whether you are ready to step through.